everyone. Let's start. My name is Dr. Maqbool. I'm serving as assistant professor in Department of IT and CS at Park Austria Fachhochschule. Basically, Fachhochschule is a German word. It's from Austrian German language. Fachhochschule means Institute of Applied Science and Technology in Haripur. It's established in 2020, 3 years ago. So it's just in initial phase. So a little introduction about me. You can see my BSc MSc from Gomul University, Dar es Salaam, and MS in Information Security from HUST, Wuhan, China, and also PhD and postdoc from Austria. Sorry, I did not updated this slide with currently, and you can also visit my personal web page, and you can contact me for an email. So what is the basic idea about machine learning? I'm not did not understanding about the participant that their background is as Dr. Asher told me about microelectronics. Hopefully they will use some machine learning. So that's why I start just from beginning. So what machine learning that humans learn from past experience. For example, we are studying, so we have get some experience when we are kids. The human is kid. It's learn from experience when he are doing something, learning, for example, some sports, to go to school from class 1 and they are learning. So this is all experience. Similarly, when you are doing some jobs, it's also getting experience. So anything that human learn, basically it's learned from its past experience. For example, you are going to class, so every day going to class, it's an experience that you get some knowledge. So when we come to how a computer works, so as human learn from experience, similarly machine follow instruction given by humans. So machine they take step by step instruction which are called programs. So how build this is built by human, so machine can't do anything without human interaction or without instruction. So that's how computer works. Now when we come to machine learning, so humans train the machine. Similarly, if in a human learn from the environment, machine learn from data. And that's why we, from machine learning, mostly we come to data for the next step. We will come to that slide. So the machine, human train the machines, and some data is a human learn from experience. So experience and data are the alternative. Data is alternative for experience in human. So that's how machine learns. So why machine learning? Because they have a lot of usages in daily life application, because nowadays you can see everywhere there is artificial intelligence. So machine learning is basically part. Next we will come to that, but some application like machine can drive a car. There is no driverless cars. And machine can now detect 50 the eye diseases. It is only eye. Similarly with other diseases, there are machine learning models that are trained on the existing patient data. So also nowadays you are using your headphone, smartphone, mobile phone. You can unlock by fingerprint or by your face, because their model is trained on your face data. So because mostly alternately we speaking about artificial intelligence and machine learning. So artificial intelligence is a broad subject and machine learning is a part of artificial intelligence. And then in machine learning, we are studying different types of algorithm. It's called neural nets. And in neural network, there is internally we use deep learning. So it's basically all the parts of artificial intelligence. So machine learning is about to learn how we can teach to machine, which can perform activities same like human. So now come to some little technical words. So what is machine learning? So first step is we define some objective. If we are doing some task, we define objective. For example, you are enrolled in degree in this, students enrolled in bachelor, master degree. So their objective is to be graduate, to get the degree, bachelor or master or PhD. So then we collect data. and then we prepare the data, pre-process the data, and then we select. Number four step is algorithm. So that's basically machine learning algorithm, a lot of algorithm. We will have a look at some of this algorithm. And then we train these models, these algorithms on the data, and we apply some test data on that to how our model is works. So a question maybe about model. Model is basically a mathematical function or statistical function. We can give them some variables inside in models, and we will change. Change means we train the model. So by training means we will get their coefficients of this variable, and then we will put in the equation, that mathematical equation. So basically that's a model. And then when the model is trained, we put them, test them on some test data. And then when it is tested, we get some about 95 or more 90 plus accuracy. Then we come to some environments, to some real example, and we deploy this in some environment or in some programs or some system, because it's only one part, and we deploy it in some system. So for example, patient for listening some, this is example. So how the model train, for example, you have some patient for listening songs. So we train about there is a intensity of songs, for example, from light to soaring, and then also from tempo, relaxed to fast. So we will check every person have their own choices. For example, someone like light songs who have less intensity, somehow with more tempo. So this basically different data collected, and then we say which type of song is most likely. So the green dot shows like, and dislike means their tempo intensity is low. So similarly, we select this, for example, if Anita new data comes, for example, this A is a new point. So we predict about is in which class or in which, basically we label the data. When we label the data, then we predict. Now, for example, if another one B comes here from which it's passed, so we will take the, for example, song A is fast tempo, soaring intensity. Song B is medium tempo, medium intensity. So where these songs lie. Okay? So we will do place them somewhere in this graph. And then what we will do, if because this B did not to any class or its house, so we make another new one, a new cluster, and then we can classify. Basically, we make some classes for label data, so we can make different classes. And currently, because this lies here, the green dot, so it means we like this one. But it depends on the user which type of. So if you are regular, basically what's the scenario? For example, we take example of YouTube, and you listen songs every day. So which type of songs played? So your data is collected by YouTube, and when they next time predict you in the sidebar, they will collect similar songs to you. So basically the model is trained according to your previous playing. When you are previous, you listen how many songs in which type of song. They take their intensity level, their tempos, and then they which type of song you like it. Then they will predict same songs for you, recommend you in YouTube. So how it comes to machine learning types, there are three types: supervised, unsupervised, and reinforcement learning. So what we see now, this was actually supervised learning. In supervised learning, we have label data. So we train the model on the given data according to the label. For example, we have squares in this screen, rectangles and triangles. So we will give this label data as an input to the model. When we train, it will separate between squares, circles, and triangles. And then we put new data. We will try it on new data. So it will predict. So in unsupervised learning, there is no label data. Basically, we make cluster of them. Cluster means similar, all the data who have similar properties. And then, for example, this batsman runs and wickets. If you have data of different players, cricket, for example, so you calculate how this player, how much scores, how much he scored, and how many wickets he took. So from wickets and runs, we can classify, we can make cluster that this is the batsman and who is the bowler. Because from wickets, if he have, for example, more than 200, 100 wickets, we say it's a wicket bowler. And some are batsmen who have no wicket, but he has thousands of scores or runs. Similarly, some are in the middle, maybe who are have work as a both as a all-rounder. So basically, the purpose is that we make clusters. So this is unsupervised learning. So the basic differences between supervised and unsupervised is in supervised we have label data, direct feedback, and predict the output. In unsupervised we have no label data, no feedback, and hidden structure in data. We should find the hidden structure. And the third one is reinforcement learning. This is basically reinforcement to learn from environment. For example, if we see this is a dog, when we are kid, so we don't know what is dog, but first we see, we hear the name that this is the dog, and similarly cat. So when we differentiate between, so if this model is trained, we give these two objects, which one is cat and which one is dog. So first, if he say that the first one is cat, but actually it's dog, so it will come back because in reinforcement learning, we are giving some rewards. If we it's going right, then it will continue. Otherwise, it will come back. So if the model predicted it is dog, then it's okay. It will go further. It will get some reward. So basically, it's learned from environment, from experience. Same like when a kid is learning. For example, if a kid is playing something or doing something, and the parents guide them. If he are doing something wrong, the parent forbid it. Don't do it. See, if he are doing something right, so they appreciate. Okay, so appreciate is basically a reward. So we appreciate it for means we reward them if it's going something good. So machine learning models, there are we give input and the model, and there is the output and then feedback. So this is the model. Applications of machine learning are in different healthcare, sentiment analysis, when you are giving thumbs up, down, similarly emojis. For example, in Facebook, social media, you are putting, if there is some good post, you like it, you share it. So these are basically sentiment analysis. There is also fraud detection, e-commerce. You already use Amazon or Daraz.com, PK, similarly other website for e-commerce. You can e-commerce. So they all use machine learning. So in machine learning, let's see how some overview of some algorithms. For example, first is linear regression, decision trees, and support vector machine. There are a lot of other algorithms, but we have a little short look. So linear regression is perhaps one the most well-known and basic algorithm. It's also used in statistics, because in machine learning, basically in data science, we also studied a lot of statistics and mathematics. So it's a linear model. There is linear model means there is linear relationship between input variable and the output, the given data and the target. We also in statistics say it's target variable. So as I told before, that the model is actually a mathematical equation. So y is mx plus c. Basically, this is the model that we want to train. So imagine that we are predicting distance traveled y. So if y is a label in, we want to predict it from speed. So x, the given variable, the input variable is speed. Then our model is y is mx plus c. It's straight line equation. So c is the coefficient. There is some constant, and m is the intercept of the line. We can see by some practical example. For example, what means by linear? For example, if a rider ride a cycle and its speed is 10 meter per second, so he can go to distance 36 kilometer, for example, in 1 hour. Similarly, if it's 20 meter per second, then he will uh, traveled 72 kilometer. It means if we double the 10 to 20 the speed, then the distance will be double. So this is linear model. So similarly, if it's come to 30 meter per second, then what will be the distance? Similar, we can add 36 more from 72. So it will come 108. So what it means, if we increase the speed in the same rate, the distance will be covered more. So this is linear model, and we call it linear regression. So what be if the distance is not, so we will find this distance. Similarly, if the speed is 50 meter per second, so what will be the distance? So this what that we train the model, and we need to predict the output. So this is the graph, how speed and distance. If this line, the green line is the regression line that we will, so the data points will be above or below the this line. M is the slope of the line, this line slope, and speed is x. So this x is basically what we in the previous slide, 10, 20, 30, 40, 50. So we will give different inputs to this x variable, and then we will multiply with m, the slope, and some constant, so we will get the output. So it means that when the speed is increases, distance also increases. So this relationship is called positive relationship. If we increase the speed and the distance is decreased, then it called negative relationship. Another is about decision tree. Let's determine if you should play a golf when the day is sunny and windy. So what could you play? So we can draw a tree-like structure. For example, humidity. If it's normal, you can play. If it's high humidity, maybe you can outlook some other thing. If the weather is sunny and it's also humidity, then you don't play. Similarly, if it's overcast, you should play. If it's rainy, don't play because there is raining. So from this decision tree, we can do some prediction. The third one is support vector machine, is also widely used for classification. In support vector machine, we draw some lines. For example, this is we label sample data which tells height and weight of males and females. So we basically, like in clustering, similarly, they are also clustered, but we want to put some new data. If we got a new, so where we will place this new point, any new man, it's male or female based on the weight and height, because we don't know it's male or female, but we can predict it from. So basically we will put him here or there. So then what we need a boundary line between these two, males and females. But there is possible many lines. For example, line 1 you can draw on this way, a line 2, similar line 3, you can draw to differentiate between males and females. So all these lines, it's called margin line. So these support vectors, we have different lines which called vector. That's why it's called support vector. So distance, margin, and this hyperplane, then we can say that how much far the data point is from either set. It's if it's near to male, then we will see the new data point is with male. If it's near to female, or it's on this line, the hyperplane, nearest data point which is the nearest data point, then we can consider it in female section. So similarly, problem, you can see another problem, classifying muffin and cupcakes recipe support vector machine. So we have a data set. Mostly you will have data set. So the type is actually the label, it's muffin or cupcake. And these are flour, milk, sugar, butter, egg, baking powder, vanilla, and salt. So it's the ratio of these ingredients. Based on this ingredient, we can say that which type is. It's using support vector machine. So what is the difference between muffin and cupcakes? So basically the ingredients are different. The same ingredient, but they have different levels. So some applications of AI in social media, Facebook, Twitter, you can use a lot of, so basically AI means machine learning here. We use a lot of machine learning in social media. Facebook, they use to detect facial feature and tag your friend. If you place some picture, automatically it detects your friend, that this is your friend you want to take. So basically it's behind is machine learning. Similarly, on Twitter use also hate speech, terroristic language in tweets, they automatically detect it. Also in AlphaGo, if you say ultimate challenge for game 3 in gaming, there are a lot of machine learning used and behind it. These are all the machine learning. Similarly, nowadays chatbot, due to the large language models or natural NLP, natural language processing, chatbot who work to give you answer. Mostly website they have chatbot. They can automatically answer your queries. Similarly, in autonomous vehicles, there are no driver, which are also called driverless cars. Tesla already work and manufactured such type of cars. In gaming, mostly student play games, so AI behind is a lot of machine learning algorithms. Some modern area like Sniper 2. So these are all are machine learning models behind it. In sports, you can also have apply different types of machine learning. In banking and finance, economical data, economics data, financial data, we use machine learning. Agriculture, a lot of agriculture nowadays use application. For example, this blow river technology. We have another session on agriculture 4.0. We will discuss in a little detail. So this what in see it spray according to the computer vision technology to monitor and precisely spray. We decide on cotton plants. So they basically the monitor and then spray where it's needed. So they are machine learning model trained on such type of data. Plant takes another from also for agriculture. In healthcare, we have a lot of other, for example, in radio waves, MRI images, slices from brain, it's called neurosurgery. Also in neuro navigation, used 3D printing and 3D images are used. Similarly, natural language processing, automatic speech recognition. For example, if I am speaking, the system automatically recognizes who is speaking. And also there are text to speech. If you have a lot of books to speech, there are application available already. Speech to text synthesis and language processing technology is something, for example, OCR, optical character. Yeah, mostly in bank, you can see that if you sign a check, the check is automatically recognized by the machine. Machine translation, we translate different types of languages. And spam filtering, for example, if we have some type of emails, we can see is it spam or not. So thank you. It was a